Hey guys, today is the first lesson of Unit 8 on exponential and logarithmic functions. Today we're just going to talk about the characteristics and how to identify them and find those special pieces. Next class we'll be talking about that. So we're going to start with exponential functions. We're going to review our parent function. So the parent function is y equals b to the x power. All right, so the b is your base. All right, and that's just going to be any number. Okay, the x up here, of course, is your variable. And remember that your variable is in the exponent. So the variable is in the exponent, it's exponential. All right, so there are two types of exponential graphs. The first is exponential growth, and you have a key point at 0, 1. So it looks like exponential growth. And then the other type is exponential decay. Again, your key point is right there, but down. Okay, so now let's look at a chart kind of some different information, and we're going to compare our parent versus our transform function. So again, our equation for our parent function is y equals b to the x power. All right. For our transform function,
it's y equals a times b to the x minus h plus k. All right, so now let's talk about the base. So if the absolute value of b is greater than 1, this is an example of exponential growth. Okay, and so it'll always be an increasing graph. If the absolute value of b is less than 1, that's an example of exponential decay, and that's going to be a decreasing graph. All right, and it's the exact same thing for your transformed function. So I'm just going to put quotation marks there. All right, our key point on our original parent function graph is 0, 1. Okay, the key point on your transformed graph is going to take the form of h, comma, k plus 1. All right, the horizontal asymptote of the parent function is at y equals 0, right along the x-axis. For the transform function, it's going to be at y equals k. All right, so the domain for the parent function is unrestricted. It's going to go from negative infinity to infinity, and it's going to be the same with the transformed function, negative infinity to infinity. All right, the range gets affected because of the horizontal asymptote. So your range for your parent is from 0 to infinity. For your transformed function, it's going to go from k to infinity. All right, so let's look at some examples here. So first things first, we have y equals 2 to the x minus 3 plus 5. The base there is 2, which of course is greater than 1. So that's an example of exponential growth. Our key point is going to be at h, comma, k plus 1. Our h value is 3, our k is 5, add 1, you get 6. So our horizontal asymptote is at k, so it's y equals 5. The domain is going to go from negative infinity to positive infinity, and the range is going to go from k, or 5, to infinity. Another example, our base is 1/3, so that's an example of exponential decay. Our key point is at negative 4, 0. Our horizontal asymptote is going to be at y equals negative 1. The domain is negative infinity to positive infinity, and the range is from negative 1 to infinity. Go ahead and try that last one by yourself. So the base is 5/3, which is an example of growth. The key point is negative 2, negative 8. The horizontal asymptote is at y equals negative 9. Domain is negative infinity to positive infinity, and the range is from negative 9 to infinity. So now let's talk about logarithmic. So we're going to review our parent function. That is y equals log base b of x. So notice where your base is. That's just going to be a number. Okay, your default on your calculator is going to be log base 10. That's what your calculator defaults to. So this is what your parent function of your log looks like. Your key point is now at 1, 0. A good way to remember that is the word log or logarithmic. You could think of it as a 1, 0 there. That's your key point. So let's take a look at our chart. So the parent, y equals log base b of x. The transform function is y equals a times log base b of x minus h plus k. Key point should be 1, 0. The next key point, or pretty point, is 10, 1. There's not a lot of really nice things to look at, so we will be using our calculator to find some points. The key point for your transform function is going to be h plus 1, k. Notice kind of its opposite of what it was for your exponential. So these guys have vertical asymptotes. So vertical asymptote is at x equals 0, which is the y-axis. Transform function is at x equals h. All right. Our domain is restricted by our vertical asymptote. So your domain is going to go from 0 to infinity for your parent. Your domain is going to go from h to infinity for your transformed. And this time the range is unrestricted. So negative infinity to positive infinity for your range for both your parent and your transformed function. Okay, so now let's look at some examples. So here we go. We have y equals log of x plus 6 minus 1. So your key point there, remember, is your h plus 1. So our h is negative 6 plus 1 is negative 5, comma k. Vertical asymptote is x equals negative 6. Domain goes from h to infinity, and the range is unrestricted. Okay. For your next one, y equals log of x minus 3 minus 4, your key point is going to be, well, since your h is 3, add 1, that's 4, comma negative 4. Vertical asymptote is at x equals 3. Domain goes from 3 to infinity, and the range is unrestricted. Go ahead and try the last one on your own. So you have y equals log of x plus 7 plus 2. Your key point is going to be at negative 6, 2. Vertical asymptote is going to be at x equals negative 7. The domain goes from negative 7 to infinity, and the range is from negative infinity to positive infinity.